This word is now pronounced arithmetic. Okay? And again, most people forget it changes when you're talking about sequences. It's just, you just got to know what it is. Just like most things. Arithmetic. So remember the accents on the arith, and then you say metic. And a sequence is just a list of numbers or terms, which we will, in general, the number of term is called n. It didn't really tell you that very clearly in the story, so I'm writing my n above the word terms with a common difference. So whenever you see an n, we're going to color blue. That n is a part of the formula. Okay, so if you see an n, it means which term number do I want to find, or in general, it's term number n. Then the common difference, we're going to use it with an orange. And instead of writing out the word common difference, we use the letter D right here. So that's not difficult to find. For me, probably the most difficult thing is, why did they call it a difference if I'm adding to get the next term? Well, technically, the difference between 0 and 6 is 6. So they're not, they're not wrong. It's just, when we think of I think of the word difference, I think of the subtraction problem. But it's not just subtract, it's also add. For an arithmetic sequence to be an arithmetic sequence, that has to be alike. So if I add 6, 6, 6, and then a 3, it's not an arithmetic sequence. Now it's following a pattern that we need to be good at noticing, and all you can do is work with the evidence you have. So we don't know what happens in the future. All we know up to this point in time, the difference was constant, and therefore it is an arithmetic sequence. Okay? So we got two rules. I call them formulas. They call them rules. Because rules are formulas. And I use a yellow so I can color on top of it. Because I want to pick out for you what your recursive rule looks like and what your explicit rule looks like. You notice I like the explicit rule. I'm biased because it's less pencil. Just saying. Recursive rule has its necessity. Explicit rule is a simpler story. So that's why I'm biased like that. So, but you can decide when you're working with them, which one do you like better? It's every right. We have every right to have opinions like that. All right. So it says use common difference D to write rules for an arithmetic sequence. A recursive rule has this general form, and so this symbol here, this variable here, stands for the first, and this is green, okay? A is green. A is the first term value. So that's where you look to fill in A in the recursive formula and in the explicit formula. So because 0 in this example was the first term, you see the 1, that's n. First term here. And then any n after it, you take n minus 1 and add the common difference.
Now, when I put blue on my yellow, it looks green, so I apologize for that. I can tell from my eyes. I don't know if you guys can see that. So that's supposed to be blue. And the difference in this case was 6.
So you notice what I colored, okay?
The A and the D changed, but you see how everything else, like even though I colored the N, it's same over here. N, missed that one, sorry.
Okay, the story is just written in particular
Using A and D.
The rest is a part of the story.
Why do we say after 2?
It's always after 2 unless it's not. But in this case, recursive rules could look a little different. If you Google recursive rules, yeah, might not match this one. Okay, so we're in this local idea. We're in local. We got to take. This is brand new. I'm thinking. You guys ever do this before? Ever written sequence rules? You remember? I don't. Yeah, they just plop this in the middle of, or towards the end of Algebra 2. So, but you can learn it sometime, because obviously it has a STEM purpose. Whether you're trying to find a pattern or whether you're trying to find like the 15th term of a pattern, that's where it comes in handy. And computers can generate this, yes, but remember this was created. We are standing on the shoulders of giants. They want you to know that this started somewhere before computers, okay? So that's the recursive rule. It's a long story, longer than the explicit rule. I'm using yellow on both because I want you to, these are where you're going to get your information you need to tell me you understand this lesson. Okay, so an explicit rule just has N in general, and you take the term number before the one you want to find and multiply it by your common difference. So in the recursive rule, it's an addend, and in the explicit rule, it's a multiplier. In the recursive rule, you list A out separately, and in the explicit rule, A's in the formula. Okay? And this is not easy, guys. It's not, you know, this is new stuff to you. So that's why it seems like silly, but it's really good. For me, the colors are helpful because then it draws my eyes to where I should find my information. So A is 0, D is 6. So that's where they get this information. You're going, well, that's not so bad. That's not so bad. If I'm supposed to write an explicit rule from a list of numbers that have a pattern, I can do that. I can find A. You just look at the first term value. I can find the difference. Just figure out what do you do to the first one to get the second one, get the third one, like that. If they've already tagged it as a sequence, you don't have to go that much. If you're trying to find out if it's a sequence, you do have to go all, you know, as much as information as they've given you. Now, there is one more step. And so I will tell you on the homework whether you have to do this step or not. They simplified this. This is nice to have it in this form because you see the first term, you see the common difference. But if you simplify by distributing the 6 and combining like terms, you get this result. And I will warn you on the homework. There's only 9 problems on the homework. So either you'll be writing an explicit rule, a recursive rule, or finding a term number on those 9 problems. But I'll warn you the form they want, so you won't get it wrong just because you put it in the wrong form. If you're paying attention, you know, I promise I'll give you a heads up on that. Okay. Let's practice. First, we have to determine if it's arithmetic, and then if it is, we march on with finding D, and then, oh, we only have to write the explicit rule. Yay. So first it's a yes or no, and then we find D and write the shorter, sweeter rule. So let's see. What do I do to -1 to get 2? I add 3. What do I get 2 to get a -3? I take away 5. Has to be constant. I have to add 3 every time or take away 5 every time. I can't go back and forth and have different values. That is not a sequence. Okay, 2, -2, -2, -2. So from the information they gave me, I see that D is a -2. A is 14. Let's write our story. Explicit says any term of the function is found from taking A plus D times n minus 1. Now they did not, for number 2 on this reteach worksheet, they didn't simplify. You could have, you just distribute and then combine like terms, but you don't have to. So what did I just put? A. See that A? I got it there. Wrote it there. Okay. And plus D. They were very. They like. I could have wrote subtract 2, but they wanted you to like point it out very explicitly what D was, and then you see how n minus 1 stays the same. That's just stays. Okay. So if I wanted to find the 20th term of this list, I don't have to list out 20 times. I just put 20 where n is. So if I take 14 times a -2 times 19, bam, I've got the 20th term. That's what the n means, okay? Term number. First, second, third, fourth, fifth, sixth, thousandth. All right, we'll check the next one, if you're ready. Okay, plus 3, uh-oh, plus 18. There's a no. They're only going to have us practice on 1 to find a pattern, which is okay. That's okay. At least you know how to find it. I mean, once you know, you know. They can't fool you if you know what to do. Okay? Now, number 4, they want 2 rules. And it's going to fudge into number 5. So I'm going to, even if I go off the edge, so I'm going to, we won't do number 5. We'll just do number 4 and then we'll skip to number 6. So there's plenty of room. And instead of writing out the word recursive rule, I'm just going to label it the R rule. This is not mathematical in any way, shape, or form. It's called taking notes. So sorry about that. So my recursive rule and explicit rule, I need an A and a D.
So I add 5, add 5, add 5, so my D is plus 5. So I'm just going to color code it orange, and now I'll know where it goes in the story. So recursive first. So I look at the top. It says it lists the first term.
Then put the comma. We use the word and, but we got to list 3 things, so we're going to put a comma.
Then I start my formula in general. Plus D, comma.
That's kind of, I wish it was different. I wish it was a 5 and a 3.
But that's why we color code it. This is A. This is D. And you have to be,
you have to note
that N is greater than or equal to 2.
because you don't start with a 1 because there's not a 0 value, okay, guys?
So that, and for arithmetic sequences,
There's no 0 term. Now that'll change. But did you guys see my bad writing here? Should look like that. Okay, greater than or equal to 2. There we go. So I start with putting 2 in here. In other words, when I put a 2 in here, the second term is from the first term plus 5. And then that's a problem with recursive rule. You got to know the term before it to use it.
that's another reason I like explicit, because it's in general. Start with A, and then I add my common difference times the term number before it.
So if I ask you for the 15th term, this one won't do me any good unless I have the 14th term.
Because that's what goes here. I don't put a,
I put a 15 in there.
I need the 14th term. This is the value. But here, I just put in a 15. If I take negative 5 plus 5 times 14,
I've got my 15th term.
so short and sweet, done with explicit.
But there is a reason there is recursive. There is a purpose. You just have to know them both. But if it was just me and the test, and I had a choice,
Explicit would be my choice.
Okay, this is new to you guys. Easy for me to say, right? Got to think about it. Where does A go? Where does D go? And why? Should make sense, right? Because a repeated addition is multiplication. That's why that is being multiplied. Instead of add 5, add 5, add 5, add 5, add 5, add 5, add 5. Remember, we didn't have calculators back in the day. And the person who discovered this obviously didn't in any way, shape, or form. Pencil and paper, that's how it was created. So it's good to know the inner workings of mathematics. So we're jumping to 6.
Find my A. Discover my D.
I just write it out to the edge because I can't,
Oh, I guess I could have written above here. Up here, I didn't have such a nice space. Do you understand? Anybody trouble?
Trouble. I'm adding 3 every term. As far as I know, that pattern will go on to eternity. I'm going to fudge over here
To write my recursive rule, because I need a long line. Start with my first term, comma, my formula, the term before it, plus the common difference, comma.
We always
Have to say n is greater than or equal to 2 if I start with term number 1. And eventually you can feel where the parts go. It's just when it's brand new.
got to see the pattern, right?
Okay, see if I can get this one written. F of n is first term plus common difference times the term number
before it. So
this guy is very, very useful for our assessment to find any term number in the universe
with arithmetic sequences. So this is specifically written for arithmetic sequences. Okay, you guys get it all on number 6? What's that? See the 4, find the 3, finish. Now they're easing you into these term discoveries. They just ask us to use the explicit rule given to write the first 3 terms. Well, that was nice of them. In other words, identify A, identify D, and do the arithmetic. Because it's only the first 3 terms. If it was term number 85, I'd put 85 in here and calculator it out. We use a lot of calculator on this module. Well, only 9 problems, but assess as well. Use calculator. 6, 9, 12. See what that tells me? Doctors of mathematics, can you analyze this formula and create first 3 terms for each of these sequences? A, D, add 3 times. I looked it up. It did take a mixed number, sorry. Took a half away and then took another half away. Once you see them, on all sides, I pick it up and examine it and twirl it around and think about it and regurgitate it and, yeah, eat it again. And you just got to wrestle with it. A, D, that was sure nice of them to write them all out free and clear. 20, 10, 0. And I could keep going, but they didn't ask me to do that. Don't put your colors away. We're going to color a couple more things before we say goodbye. Take one and pass it back. Take one and pass it back, please. Take one and pass it back. One and pass it back. Extras back here. We're going to use the same color coding.